In this video, we're going to look at a story problem that involves distance, rate, time, and a kind of an upstream, downstream situation. Another type of story problem that's like this, as you'll see with airplanes, is with the wind, against the wind. So these kind of all fit in the same category of problem. So let's take a look and see what we got here. A cruise boat travels 60 miles downstream in 3 hours and returns to its starting point upstream in 12 hours. Find the speed of the stream. Okay, well, anytime you have these distance, rate, time problems, I think it's a good idea to draw a picture. And this could be a little bit scary, me drawing a picture, so I'm not going to get too fired up. I'm not going to be drawing any boats or anything. Maybe I'll draw a little water. Oh, let's see. There we go. Okay, so I'm going to do an arrow for which way the current's going. Okay, so this is going to be downstream when they're going this direction. So it says a cruise boat travels 60 miles downstream in 3 hours and then returns to its starting point upstream in 12 hours. So the important thing to realize there, as far as the distance, they went 60 miles downstream. How far did they go upstream? Exactly. Hopefully you got it. It's 60 miles upstream because they returned to their starting point. So if they started here and they went downstream to here, 60 miles... Let's do that in some other color. Oh, beautiful. Whatever this is, I don't know. So there's your 60 miles. They went downstream, and then they turned around and came back. It took them a lot longer because they were fighting the current, but they still went the same distance. Okay, so let's go over here to this box. Now, you might want to pause it and write this box down. This is a good way to organize your information on certain types of story problems, is to use a box. And the way the box is set up, the top row here is where your formula is going to go. And usually this upper left-hand corner doesn't get used at all, so I just kind of scratched it out. The formula that you need to know to solve distance problems is rate times time equals distance. R times T equals D. R is rate, T is time, D is distance. And in this one, we have two rows, and one row is going to represent upstream, and the other one's going to represent downstream. And there's a lot of these types of distance problems where maybe one represents one guy. You know, there might be two people in the problem, and your first row will represent one person, the other one will be another person, or, you know, whatever the situation is. Okay, so let's fill in what we know. Well, we certainly know the distance for upstream and downstream. That's 60 miles. We talked about that over here. And maybe you want to make a little note to yourself about what your label is. That's miles. Our time is going to be in hours because they gave us hours here. So then your rate is going to be miles per hour. That's how those relate to each other. So they told us it took 3 hours to go downstream. So time downstream is 3 hours. And 12 hours to go upstream. So time upstream is 12 hours. Okay, here's the tricky part about these wind, water, current, or air, I guess I should say wind speed or current type problems. The rate is affected by two things. It's affected by the boat or the airplane in a different case, and the current or the wind as far as an airplane goes. So in our case, we got the speed of the boat and we got the speed of the current. Those are two things we don't know. So we need to make variables for those. So let's let B equal the speed of the boat. We usually say in still water, which means no current at all if there was no current affecting it. And then we can let C equal the speed of the current. So both these variables are going to affect our rate going upstream and downstream. Now when we're going, let's do downstream first, okay? When we're going downstream, what happens? The current pushes us faster, right? So we're going to go faster. If it was just us in our boat, we'd be going along B miles an hour, and then all of a sudden current comes along, pushes us. So we're going faster, so we're going B plus C. Oh, I wrote that in the wrong spot. Let's get rid of that. I was talking about downstream, wasn't I? Downstream, B plus C. Now when we're going upstream, we have the opposite situation. We might be going along B miles per hour, but then the current is pushing against us, which makes us slow down. So upstream is B minus C. And again, it's the same kind of thing with wind problems. It would be like the plane plus the wind, the plane minus the wind. And in some problems, they'll tell you the current, and they'll leave out the time. Or they'll tell you the boat and leave out the current. Or so really you've got almost like 4 different numbers that you're dealing with. I was going to say variables, but 4 different types of numbers: the speed of the boat, speed of the current, time, and distance. So now we've got 2 equations that we can make. We can make one equation from the top row, the upstream situation, and one equation from the bottom row, the downstream situation, and then we'll have our 2 equations with our 2 unknowns. So for the top row, we just use the formula, rate times time equals distance. So B minus C, got to put that in parentheses, times 12 equals 60. And then the bottom row, B plus C times 3 equals 60. Just following the formula. So, oh man, there's so many different ways to do this from here. I should show you a shortcut for this one. Let me write these out over here. I see a shortcut. And, you know, for most of you, when you get to this point, oh, I should say a lot of people, when they get to this point, they're pretty good at solving it. That pink's a little nasty. Let's go to purple. They would distribute the 12 and then distribute the 3 and then maybe line these up for elimination. But you know what I see right here is I see that 12 goes into 60 and so does 3 go into 60. So I could actually, instead of distributing the 12, divide both sides by 12 here, and it's going to come out really nice. I get these 12s canceling, and I get B minus C equals 5. And on this one, I could divide both sides by 3, and I get B plus C equals 20. Those are nice. Now, if I had a number over here like 65 or 73 where 12 didn't go into it very nice, then I probably wouldn't divide by the 12. I'd probably go ahead and distribute the 12 and then go about solving it a different way. But this one was just too nice, because now it's all set up, you know, for elimination also. If I move that equation under there, I get B minus C equals 5. Add them together. Now be careful here. B plus B is 2B. The C's drop out. I get 25. Divide both sides by 2, and we get 12.5. Okay, but they asked me, let's see, what did they ask? Find the speed of the stream. So what they want to know is the speed of the current. So we have to figure out C. Well, we can just take our B value right here and put it in there. You could put it up here too. The B plus C equals 20. It doesn't matter. Just put it back into one of these equations. Actually, you could put it back into these big ones that we first got, but I mean, why would you do that? That's just more work. They'd still get the right answer. So 12.5 minus C equals 5. Let's go ahead and add the C over to keep it positive. And I'm going to run into my little arrow. 12.5 equals 5 plus C. Subtract 5 from both sides. 7.5 equals C. I mean, you could have subtracted the 12.5 and then divided both sides by -1. That would work as well. But 7.5 is our answer. So that's the speed of the current. And to make it all nice, we would want to say the current is 7.5 miles per hour. Always good to answer a story problem with a little phrase or something and then label it with the correct label, miles per hour. I hope that helps. And you might want to try solving this by distributing the 12 and distributing the 3 and then using elimination and see if you can get the same answers. That'd be a good exercise.